A very warm welcome to all the students. Today we are going to discuss Chapter 10, Atmospheric Circulation and Weather Systems from the textbook, Fundamentals of Physical Geography for Class 11th. In the first part of the video series, we will learn the following topics. What is atmospheric pressure? Causes of pressure differences. Vertical variation of pressure. Horizontal distribution of pressure. World distribution of sea level pressure and forces affecting the velocity and direction of wind. What do you mean by general circulation of the atmosphere? The pattern of the movement of the planetary winds is called the general circulation of the atmosphere. Do you know, children, during the age of discovery, that's from 1400 to 1600s, there was a lot of interest in the large-scale wind patterns of the atmosphere. After much research, it was found that there exists pressure bands. Air expands when heated and gets compressed when cooled. This results in variation in the atmospheric pressure. The differences in atmospheric pressure causes the movement of air from high pressure to low pressure, setting the air in motion. Atmospheric pressure also determines when the air will rise or sink. Air in horizontal motion is wind. The wind redistributes the heat and moisture across latitudes, thereby maintaining a constant temperature for the planet as a whole. The vertical rising of moist air forms clouds and brings precipitation. What is air pressure? Since air has mass, it also has weight. The pressure of air at a given place is defined as a force exerted in all directions by virtue of the weight of all the air above it. The weight of a column of air contained in a unit area from the mean sea level to the top of the atmosphere is called the atmospheric pressure. The atmospheric pressure is expressed in various units. Now, how is it measured? Atmospheric pressure is the weight of the column of air at any given place and time. It is measured by means of an instrument called barometer. The units used by meteorologists for this purposes are called millibars, and it can be written as small mb. 1 millibar is equal to the force of 1 gram on a square centimeter. A pressure of 1000 millibars is equal to the weight of 1.053 kilograms per square centimeter. It is measured by the aneroid barometer or mercury barometer. Vertical variation of pressure. In the lower atmospheres, the pressure decreases rapidly with height. At the height of Mount Everest, the air pressure is about 2/3 less than what it is at sea level. The decrease in pressure with altitude, however, is not constant. Since the factors controlling air density, temperature, amount of water vapor, and gravity are variable, there is no simple relationship between altitude and pressure. In general, the atmospheric pressure decreases on an average at the rate of about 34 millibars every 300 meters of height. The vertical pressure gradient force is much larger than that of the horizontal pressure gradient, but it is generally balanced by a nearly equal but opposite gravitational force. Hence, we do not experience strong upward winds. Due to gravity, the air at the surface is denser and hence has higher pressure. Since air pressure is proportional to density as well as temperature, it follows that a change in either temperature or density will cause a corresponding change in the pressure. A rising pressure indicates fine, settled weather, while a falling pressure indicates unstable and cloudy weather. Now we will talk about horizontal distribution of pressure. Small differences in pressure are highly significant in terms of the wind direction and velocity. Horizontal distribution of pressure is studied by drawing isobars at constant levels. Now, what are isobars? Isobars are lines connecting places having equal pressure. In order to eliminate the effect of altitude and pressure, it is measured at any station after being reduced to sea level for purposes of comparison. The spacing of isobars expresses the rate and direction of pressure changes and is referred to as pressure gradient. close spacing of isobars indicates a steep or strong pressure gradient, while wide spacing suggests weak gradient. The pressure gradient may thus be defined as the decrease in pressure per unit distance in the direction in which the pressure decreases most rapidly. These are distinctly identifiable zones of homogeneous horizontal pressure regimes or pressure belts. On the Earth's surface, there are in all 7 pressure belts. Can you name them? Yes, they are equatorial low pressure belt, the subtropical highs, the subtropical lows, and the polar highs. Except the equatorial low, all other forms have matching pairs in northern and southern hemispheres. There are 2 terms which you should know: closed isobars or closed pressure centers. Low pressure system is enclosed by 1 or more isobars with the lowest pressure in the center, and high pressure system is also enclosed by 1 or more isobars with the highest pressure in the center. Now we will talk about the world distribution of sea level pressure. The atmosphere exerts a pressure of 1034 gram per square centimeter at sea level. This amount of pressure is exerted by the atmosphere at sea level on all animals, plants, rocks, etc. Pressure belts in July. In northern hemisphere during summer, with the apparent northward shift of the sun, the thermal equator, that's the belt of highest temperature, is located north of the geographical equator. The pressure belts shift slightly north of their annual average locations. Whereas the pressure belts in January, here during winter, these conditions are completely reversed and the pressure belts shift south of their annual mean locations. Opposite conditions prevail in the southern hemisphere. The amount of shift is, however, less in the southern hemisphere due to predominance of water. Similarly, distribution of continents and oceans have a marked influence over the distribution of pressure. In winter, the continents are cooler than the oceans and tend to develop high pressure centers, whereas in summer, they are relatively warmer and develop low pressure. It is just the reverse with the oceans. Near the equator, the sea level pressure is low and the area is known as equatorial low. Along 30 degree north and 30 degrees south are found the high pressure areas known as the subtropical highs. Further polewards, along 60 degree north and 60 degrees south, the low pressure belts are termed as subpolar lows. Near the poles, the pressure is high and it is known as polar high. These pressure belts are not permanent in nature. They oscillate with the apparent movement of the sun. In the northern hemisphere, in winter, they move southwards and in the summer, northwards. Now we'll talk in detail about the major pressure belts of the earth. The first one is equatorial low pressure belt or doldrums. Lies between 10 degree north and 10 degree south latitudes. Width may vary between 5 degree north and 5 degree south and 20 degree north and 20 degree south latitudes. This belt happens to be the zone of convergence of trade winds from 2 hemispheres from subtropical high pressure belts. This belt happens to be the zone of convergence of trade winds from 2 hemispheres from subtropical high pressure belts. This belt is also called the doldrums because of the extremely calm air movements. This position of the belt varies with the apparent movement of the sun. Its formation. As the region lies along the equator, it receives highest amount of insolation. Due to intense heating, air gets warmed up and rises over the equatorial region. These are known as convection currents. Whenever there is vertically upward movement of air, the region at the surface will be at low pressure. Thus, the belt along the equator is called equatorial low pressure belt. What is the climate like here? This belt is characterized by extremely low pressure with calm conditions. This is because of the absence of surface winds, since winds approaching this belt begin to rise near its margin. Thus, only vertical currents are found. As a larger part of the low pressure belt passes along the oceans, the winds obtain huge amount of moisture. And vertical winds, the convection currents, they carry moisture and form cumulonimbus clouds and lead to thunderstorms. Convectional rainfall is also common in equatorial regions. In spite of high temperatures, cyclones are not formed at the equator because of zero Coriolis force. You can see this in the diagram given. We will talk about subtropical high pressure belt or horse latitudes. The subtropical highs extend from near the tropics to about 35° north and south. Their formation. After saturation, that's complete loss of moisture, at the ITCZ, the air moving away from equatorial low pressure belt in the upper atmosphere becomes dry and cold. This dry and cold wind subsides at 30° north and south. So the high pressure along this belt is due to subsidence of air coming from the equatorial region, which descends after becoming heavy. The high pressure is also due to the blocking effect of air at upper levels because of the Coriolis force. The climate of this place. The subsiding air is warm and dry. Therefore, most of the deserts are present along this belt in both the hemispheres. A calm condition that's anticyclonic with feeble winds is created in this high pressure belt. The descending air currents feed the winds blowing towards adjoining low pressure belts, and this belt is frequently invaded by tropical and extratropical disturbances. Why this belt is also known as horse latitudes. The corresponding latitudes of subtropical high pressure belt are called horse latitude because in early days, the sailing vessels with cargo of horses found it difficult to sail under calm conditions of this high pressure belt. They used to throw horses into the sea when fodder ran out, hence the name horse latitudes. In this belt also, we have large number of deserts located. Now the third belt is subpolar low pressure belt. Located between 45° north and south latitudes and the Arctic and the Antarctic circles. Owing to low temperatures in these latitudes, the subpolar low pressure belts are not very well pronounced year long. On long-term mean climatic maps, the subpolar low pressure belts of the northern hemisphere are grouped into two centers of atmospheric activity, the Iceland Low and the Aleutian Depression. Such belts in the southern hemisphere surround the periphery of Antarctica and are not as well differentiated. How are they formed? These are dynamically produced due to Coriolis force produced by rotation of the Earth on its axis and extent of air as a result of convergence of westerlies as well as polar easterlies. We will be talking more about these winds in the next topic. Seasonal behavior. During winter, because of a high contrast between land and sea, this belt is broken into two distinct low centers, one in the vicinity of the Aleutian Islands and the other between Iceland and Greenland. During summer, a lesser contrast results in a more developed and regular belt. The climate of this area is a contrast between cold and warm air masses. It produces polar jet streams which encircles the Earth at 60° latitudes and is focused in these low pressure areas. Due to a great contrast between the temperatures of the winds from subtropical and polar source regions, extratropical cyclonic storms or lows are produced in this region. Now we will talk about polar high pressure belt. The polar highs are small in area and extend around the poles. They lie around poles between 80° to 90° north and south latitudes. Their formation. The air from subpolar low pressure belts after saturation becomes dry. This dry air becomes cold while moving towards poles through upper troposphere. The cold air, it becomes heavy on reaching poles, it subsides and creates a high pressure belt at the surface of the Earth. The lowest temperatures are found over the poles. Now, factors controlling pressure systems of the Earth. There are two main causes, thermal and dynamic, for pressure differences resulting in high and low pressure systems. Thermal factors are when the air is heated, it expands and hence its density decreases. This naturally leads to low pressure. On the contrary, cooling results in contraction. This increases the density and thus leads to high pressure. Formation of equatorial low and polar highs are examples of thermal lows and thermal highs respectively. Dynamic factors. Apart from variations of temperature, the formation of pressure belts may be explained by dynamic controls arising out of pressure gradient forces and rotation of the Earth forces. Now, there are two main forces which affect the movement of the winds. The first one is pressure gradient force. and the other is frictional force. The third important force which acts is the Coriolis force, which is one of the most important force acting on the surface of the earth. The rotation of the earth about its axis affects the direction of the wind. This force is called the Coriolis force after the French physicist who described it in 1844. Coriolis force deflects the wind to the right direction in the northern hemisphere and to the left in the southern hemisphere. The deflection is more when the wind velocity is high. It is maximum at the poles and is absent at the equator. The Coriolis force acts perpendicular to the pressure gradient force. I hope you have understood the relation between pressure and winds. The wind circulation around the low is called cyclonic circulation. Around a high, it is called anticyclonic circulation. The diagram is given for a better understanding. This is all we will do in part 1 of chapter 10. The new terms which we have learnt till now are air pressure. It is measured with the help of a mercury barometer or aneroid barometer. Isobars. These are the lines connecting places having equal pressure. The force exerted by the rotation of earth is known as the Coriolis force. The rate of change of pressure with respect to distance is the pressure gradient force. Frictional force affects the speed of the wind. It is greatest at the surface and its influence generally extends up to an elevation of 1 to 3 km. Over the sea surface, the friction is minimal. When isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is known as the geostrophic wind. By the end of the chapter, you should be able to define atmospheric pressure, how is it measured, differentiate between vertical variation pressure and horizontal distribution of pressure, explain the world distribution of sea level pressure, diagrammatically explain the major pressure belts of the earth, relate the factors affecting the velocity and direction of wind, that is pressure gradient force, frictional force and Coriolis force, and relation between pressure and wind with reference to geostrophic wind. There are a few questions given for self-evaluation. Do attempt that. I hope you have enjoyed understanding this part of the chapter. Thank you.